We have tools there when you put in the ergonomic part and you do things in virtual reality, you can evaluate who is supposed to do this job so that you can recommend to somebody, put so-and-so on this job. The most expensive and the most critical resources you have in your factory and your company are the people. You don't want anybody to get hurt.
Today I speak with Tom Hoffman, Director of Business Development for Digital Enterprise at Siemens. His early adoption of CAD and other new engineering design technology definitely set the stage for his career as an engineering design supervisor. Tom's roots in the Detroit area, the Motor City, home to Ford and GM, may have played a huge part as well. He even became GM's senior manufacturing engineer before his business development role at Siemens. Keeping in step with other Siemens decision makers, Tom has always kept the latest manufacturing trends and tools in mind, from development to deployment, improvement, and integration, all while embracing them and making them understood from the engineer's desk to the boardroom to manufacturing lines and prospective clients in between. What challenges can a manufacturer face when adopting new hardware and software for their factory floor? What can stop a project in its tracks before it even starts? What can Tom tell us about Siemens' involvement in LIFT, a collaborative space supporting academic programs, large manufacturers, and smart engineering initiatives for the Department of Defense, and how they make sure their mission-critical engineering talent pool, educational resources, and training are accessible to all? This is my conversation with Tom Hoffman. We live in a time where design and technology touch every aspect of our lives. But where did it all come from? Who designed it? How was it built and brought to market? What will it look like in a year, 2 years, 100 years? From the phones and smartwatches that help us in our day-to-day to the cutting-edge spaceships and 3D printers that are leading us into the future, modern design is constantly shaping the way we work, communicate, problem solve, and play. And every new design, big or small, starts with an idea and a bill of materials. I'm Majenta Strongheart, and this is The Bomb, where we talk to leading innovators in the tech world and celebrate the transformational power of design. Welcome to The Bomb, Tom. I'm really excited to be here in Detroit, Michigan at the LIFT Center, where Siemens has this incredible display, operational, working, live display behind us, and I'm excited to learn more about your role here. Thanks for joining us.
Thanks, Majenta. I appreciate it. So again, I introduce myself as Tom Hoffman, a business manager here. One of a team of about 6 or 7, kind of grows and declines as we require people to be here. And yeah, it's a great environment to learn more about digital threads and what Explore means to various companies.
Awesome. Let's get into it. Some folks who are listening are just listening and they're not going to see the visuals. Some people will be lucky to watch the visual and then they'll see this epic background we have here before us. But I would love for you to explain, as technical as you want to get, what exactly is set up behind us, because this is kind of the most magical part, I would say, of the experience here. It's the most in-depth example of Siemens' full kind of cycle solutions in action. So can you describe a little bit of what's going on behind us?
Let's see if I can do this. Adequate enough for somebody who is not seeing.
Right. Imagine they're not seeing.
So if you can imagine a 10-foot by 60-foot space, that's where this sits. When we started this journey, somebody in management came to us and said, you need to build us a manufacturing line. And this will show you the differences between people that have not necessarily been in industry. And we said, well, what are we building? And they said, we don't know. Well, that's hard to build, right?
Yeah.
So me and my colleague, Ed Shenholz, who's not here, we've known each other for over 30 years. So they said, you two guys figure out what that thing is going to look like. They provided us what I consider in the old days, it would have been a bar napkin sketch where somebody, in today's world, it would have been somebody gave me a PowerPoint slide that says, hey, look at all these boxes we put here. I said, something like this.
Make it happen.
Make it happen. So what we did is that the automotive story, which is first out of the gate here, is tied to an electric vehicle, right? The story being that you're going to take this vehicle, turn it into an autonomous vehicle, so on and so forth. The manufacturing line behind us, we developed as a 7-station manufacturing line, okay? Over 60 feet. And the premise is that that line is a smart manufacturing line. So it has to be good enough to handle the automotive piece that we built, which is coming out of the electrical system for the E-rod, as we call it. It also has to adapt so that if we want to build something in the industrial machinery market, we will put it on the conveyor system. and also with the heavy equipment side. So it's a smart manufacturing system that has learning capabilities, AI-ish in nature, but more or less a system that starts to get information, starts to provide you information so that you can start to optimize the system, right?
It's responsive and adaptive.
Absolutely. It's all depends on what level you want to get into integrate, because the big thing that we have going on is that this line has some redundancy in it. So if you were to be here with this line, I've got the first station has an inverted robot that's doing some automatic bin picking based on a camera and putting that into a kit. That kit shuttles to the next station or a cobot. So these cobots become very easy to work with. They're human friendly. You don't have to worry about getting hurt.
Right. And this was something huge you mentioned in our tour, which is, it needs to be almost reasonable for a hybrid space potentially, where it's not all machines or all humans, but like you said, it's collaborative between both spaces, so that I think it's also more approachable for some of the clients to imagine in their space if they're a little slow to want to adopt some of these things, right? Or don't want to do the whole system all at once.
That's right, because in a lot of cases, some of the customers now cannot dedicate a specific line to if they had high volume on something, great. But sometimes they have to do we used to call it the one-offs or first one build, whatever that technology.
The first phase of it all.
Yeah. So in our case, the system is going to be connected to the backbone. So as you develop a process plan, the process plan will evaluate against the live system to find out if you have all the right tools, capability, and then schedule itself into there. So we're trying to automate the process of, hey, I have to do additional builds, and somebody comes to you and says, hey, can you do this for me? And so all of a sudden you're disrupting your production system to do something that's a one-off. So in our case, that's what the manufacturing system has been designed for. It's loaded with Siemens technology to not only monitor what's going on. I mean, we have cyber protection on it. We cyber protect each station so we don't take big things out of production. We also have the ability we have edge devices. We have connectability through this machine. Therefore, we're pulling data, right? Data is a big thing. So what do you do with the data? Then you can tie that data back to your virtual simulations. Once you do that, you can start to make recommendations about how to optimize the line. So this line is made up of a ton of technology. We have a lot of partners that helped us with this. We've got conveyor systems that are electromagnetic, so it means we can stop and start things at will. We can put things where we want to put them. It actually created a bigger issue for us because I've got 3 lanes of conveyors.
As those things do sometimes.
And it's a traffic flow problem because I can do anything I want. It's like I attribute it to those of us that go and drive, right? We come to a 4-way stop and it's like, okay, who goes first?
Right.
I have the same problem on the manufacturing line, right? So you have to really be able to take your automation and say, oh, who has priority? What is the priority? What is top? Where's it going? So, and you're right. We specifically did a mix of automation and manual because we have tools to evaluate the manual to say, all right, am I going to hurt the worker? Because as I state, and I stand by this, the most expensive and the most critical resource you have in your factory and your company are the people. You don't want anybody to get hurt. Every day I come in this building, I look at the lost days chart, and as long as it keeps going up, I'm good. Yeah. Right. And so we have tools that'll evaluate who can do a job. In the old days, somebody would say, okay, just put that person on the job. And you find out that they were either not tall enough, fit enough, maybe they couldn't lift what was done, and somebody put them in harm's way, right? So we have tools there when you put in the ergonomic part and you do things in virtual reality, you can evaluate who is supposed to do this job so that you can recommend to somebody, put so-and-so on this job.
Prevent accidents and things from happening.
That is one of the purposes. Now, what that yields is a slight issue is the fact that you see I got an electrician on here. The other guy was factory automation. So luckily, I don't have to pay for him. Luckily, his boss says, yeah, you got to finish this, right? I would love, and I've said this to management across the DI, is that I would love to have a bunch of full-time equivalents here that, and it won't take 100% in terms of maintenance, but there's going to be stuff that breaks, stuff that needs
who
to
are
be changed.
capable to really maintain it.
Yeah, and there's some things that I'll have to have contracts on a yearly basis, right?
Yeah,
like the electrical system, we're not.
Yeah, we're not taking that on.
I'm not touching the 480 in that wall over there. I'm not doing it.
Yeah, no, that makes sense.
Yeah, so this is the part of the planning that you go after, and you know, when this was started, marketing took the lead on this. I mean, Bill O'Neill's been a part of this for a long time, especially with MXD. But then they made the investment here at Lyft, and then it came at a time when COVID hit, and then all of a sudden they had some extra money sitting around, right? And you know how that is. Even in my days previous to this, I used to work at General Motors, and if you didn't use the money,
it'll disappear.
They lost some money. And usually what happens is if you had $10 million.
And it might affect the budget the next year. And then next year
they said, well, you only spent $9 and you got $9, right?
Of course.
So, I mean, so the issue here is that right now, a lot of the budget control is through marketing.
Yeah.
And you know, and a lot of the kids here, they will pass through and go somewhere else. And I told them, I said, I don't want this to be a sawtooth.
Yeah.
And what I meant by that is that they learn, and they're great. And then when they leave and I get somebody new, and it's like, I don't want to keep going
or
back.
the revolving door.
Yeah, well, the revolving door, if it was just simply a revolving door where I left and you came in and the knowledge was the same, you don't miss a beat.
Sure.
You know, as I said to a long time ago, 40 years ago, when I got into the business, I had a boss tell me that if I wanted to move up, I had to make sure somebody could take my job. And his analogy to that was, if you got hit by a beer truck, Hoffman, what would I do?
Yeah. Yeah, it can't
you have
be
to
just
think of that. So,
out of luck. Yeah.
So anyways.
Definitely. No, those are good notes and reminders. So I want to shift a little bit and go to the Tom Hoffman origin story and learn more about how you got all of this expertise that you're able to apply to this role now, and this amazing space that, you know, is helping showcase these Siemens solutions in a complete kind of, demo. So where did you first get involved in manufacturing and engineering? And
so 40 years ago, right? You get in. So I should say it was before 40 years ago. So my father, and being born in Michigan and growing up in the Detroit area, manufacturing is in your blood right from the start, right? Obviously, it's not Silicon Valley here, although things are kind of changing. So my dad worked at a machine shop, eventually became part owner of the machine shop. So I spent time learning how to machine parts, cleaning the building. So all of a sudden you start by learning by osmosis. And then you go to school, you come back and you get hired into an engineering firm that was doing work for the automotive business as a line builder, more or less. They were one of the first back in early 80s to make an investment in CAD systems. So when I first got there, I was a draftsman. You know, you went out there, you drew lines, and I still think it set the tone for knowledge, because you had to really try to think what 3D is. And you were doing it in your mind rather than with a computer that you could just rotate it around and see it, right? So orthographic projection and everything else. Right. So I started off, and I was lucky enough to start off on the board for a while. And then they said, you'll be a good candidate to go run these computer systems. So back then it was an Applicon, 4 terminals hanging off of the mainframe. The computer was in a controlled environment, and the hard drive was 200 megabytes in the size of a washing machine, right? So
great visual. Appreciate that for the listeners.
you learn so that was all wireframe. So it still looked like a bunch of spaghetti on the screen, and you still had to use some of your orthographic skills and projection knowledge to how to get from point A to point B.
How to attack it, yeah.
So I've been lucky enough to kind of map the career that said, okay, I started off as a designer in the automotive business, not a product designer, but tooling, weld guns, weld machinery. Then, if anybody with a history of automotive knows that it goes in cycles. So as that was going down the cycle, the company actually brought in some aerospace work. So I got really indoctrinated also into understanding how to make a jet engine, compressor blades and everything else. Wow. So and I developed different tool systems for that, which is completely different from the automotive.
Mm-hmm.
An example of that is aerospace was really concerned with space and quality of the components, so on and so forth. The people who were making tools for the automotive industry, one of the things was, hey, steel's cheap. Overbuild it so it doesn't break. We don't want to fix it later on, right? It was
totally different.
That engineering, that engineering was much more broad of make it bigger, better, and make sure it doesn't break so we don't have to fix it.
Right.
So, that I went into that for about 11 years and cycle of working my way up, becoming manager of the computer systems and training people. And
the tool systems you were developing for aerospace, were they mostly, what types of machinery were you working with?
A lot of in that case, it was still assembly level stuff. So we were integrating the compressor blade methodologies of how to make them, how to then assemble them.
Okay, not necessarily the fabrication side.
Yeah,
got it.
No.
Fabrication
side. Well, I would say the fabrication side only is it related to making, like, take a compressor blade, starts off as a little billet piece of stock, round stock, gets heated, coated, gets encapsulated, then you start broaching it. So there are some machining aspects of it, but it's not like taking an NC machine, right?
Got it.
But again, my younger days, high school, I was with my father and I understood my dad was one of those people who brought home a blueprint. He already knew how he was doing it. And he'd say, how would you machine this? And then he'd put it on the kitchen table. And instead of getting dinner, I'd have a computer next to or my calculator next to me, trying to figure out how we. And
that's awesome. You were building off of that
absolutely
foundation.
And math is extremely important, which is, I have 8 grandkids and I tell them all the time, math, math, math. If you understand math and you can do math, you're in good shape. So anyways, developing tools, developing systems, then you start to work your way into a managerial role. So I did all the training. I was the one that got contacted at 1:00 in the morning when the computer system broke. I'd have to get out of bed.
You're on call.
I'd have to go into the office and sometimes spin up new disks and rebuild them. So you get an understanding of that technology. Back then, competition, right? Back then I was running AutoCAD, right? On a machine that had 640K of memory and was running at 4 megahertz. I mean, nowadays, I don't even think people know what that is.
Yeah.
Right? So, but you learn. And then, so I went from there and then, so I was mostly a user and an engineer, right? I got a call out of the blue and one of the simulation companies said, hey, we need your help. We need you to come work with us to help us develop the simulations of the future. And so it's like a big leap of faith when you've been a user and you're really used to building physical things to go into the software business. So it's like, okay, give it a try. And that was in 1991.
But also, I'm sure your experience was invaluable to that role shift.
That's what they were looking for.
You understand the end user's experience and their perspective. You were that person,
Yeah. So oddly enough, back in like 1990, Technomatics, which is a part of Siemens, right? I was probably one of the first people trained in simulation. And then in 1992 is when I got the call from a competitor saying, hey, we need your help. And you're right. It really is relative to process. We need to understand. And in that case, this is early on, right? GUI is a user experience, UI, very important because back then you found that software developers were good at developing software, less inclined to think about how the user was going to use it. Right. And so that becomes very important. And so I did that for about 5 years, and I always tell people, you get into this business and if you're good, you don't really have to look for a job.
They were looking for you.
The only time I have to do a resume is when somebody says, I need it for the file cabinet. Okay, fine, So
well, that's
then
great.
I left there and I went to General Motors because they called and said, we need your help now in implementation.
And I want to chime in there that I think that's a good note. I think a lot of people listening to this podcast too, we have some young folks thinking about career path, thinking about these different industries, getting into manufacturing, design, engineering, maybe entrepreneurship, et cetera, within maybe hardware, tech startups. But I was just talking about this with Fernando the other day for another episode of the podcast. He works at Citizen Robotics and talked about his experience in the construction industry and then seeing kind of how he wanted to get involved in some of the newer tech because there's an opportunity to, expand maybe his future and pathway within this industry because he didn't see he saw it growing in that direction. So now they're using cement 3D printers to develop, walls and things for construction, for residential construction. But I think it's really interesting. We were talking about how, oftentimes it's not the exciting or maybe the thing that's catching everyone's eye. There's maybe not even content around it, around the trades and around some of these skill sets that you need to operate this machinery. But it can be a huge opportunity to get involved. Like you started with experience on a line, or developing tools for this line. And that's gotten you so far in this industry, right? And you've been on then the leading edge of all this technology, the simulation technology. And now this is like the top tech that, facilities are integrating now, and even, learning and maybe sometimes afraid of integrating into their spaces. And you can speak from a perspective of being on that manufacturing floor and knowing kind of their pain points or maybe some of, their fears around this, which I think people kind of take for granted that some of that experience can be really valuable in a more high-tech job down the line, right?
Absolutely. And then you got to be blessed too with some managers that can espouse this, feed you. I'll give you an example. Is that I've had managers who think out of the box. And what I meant by that is that this is back in 1984, okay? One of the managers said, your job is to eventually, so I used to program some of the capabilities into the system. You get a base system and you start to program some stuff. But then my job was to take and create a menu structure of optimizing an engineering factory. So can I get 4 people to work on it, and then one person does it, and then the next person does it, and the next person does it? Eventually try to get it down to one button that says do it, that type of thing, right? And the other thing that I was always told, even at a young age, getting involved in computer systems was, okay, what you don't want to do is let data leave its source. So our kind of main thing we always said is capturing electronic data at its source, which is very digital thread-like. And this is back in the mid-'80s. Yeah. So we always said that you don't want to have data moving over here and then coming back. Now, back then, we didn't have the sophistication level that a Siemens can bring to the case. And that is, all these things they're not necessarily the same, but they're all connected to a backbone that says, okay, I can share data. I know what's there, and I'm pulling for the application based on what I need. I don't need everything. I need pieces of it, right? So, but that's a principle that you have to get. I've been involved with the right people, so I take that and I keep telling my people the same thing, right? You have to be able to make sure that you can take, and I can talk. The nice thing is that when you get raised from as a user into the software world, and then essentially into a place like this where I get to talk to customers, I've been there, I've done it. And they recognize that we have a lot of experience here at Siemens that says, let's talk, ping ideas. Again, not talking specifically applications that we have, but let's talk about what you're seeing out there and why you're seeing it. Totally. And if you look at the methodologies we have of trends and implications and all that, those things should be dominating the conversation. And so anyways, it's a lot of fun. And I always say, this business keeps your mind going. If nothing else, every day there's something to think about. Every day there's something to figure out. Here, it's like, how can we take that system and make it smarter and better and faster?
Definitely keeps you on your toes.
Absolutely.
So I'm curious, when you mentioned that you were involved in some of the early simulation software, right? Yeah. And so do you remember at that time, do you feel like you saw the future as far as what you're working on now? Yeah. Did you see it coming, or was that way beyond?
I'll give you an example of what I saw. So, as I said, you get in this, funny thing is, you get in this business, at least locally in the Detroit area, you see the same people and they're still involved, which tells you something. Well, it tells you something about the environment. It tells you that it's really an interesting environment. People love it. People can learn. There's no ceiling on what you can attain in here, right? So years ago, as I was going through that process, and if you were to go look at simulation years ago, it required big Unix workstations. Back in the day, Silicon Graphics, HP, SunSpark, all those players, right? And so that type of simulation software only ran on those platforms, usually only because those platforms had advanced graphic engine capabilities, right? So my vision a long time ago with one of the companies that wanted to hire me said, hey, can you, I said to them, they were interviewing me, I said, I have a question for you. I said, where do you believe, and this was back in 1998, where do you believe simulation will be relative to the PC market? And they said, we don't think it'll ever get there. At that point, I didn't hire into that company.
Wow.
They didn't have, so that's,
they don't have the vision.
So when you're in here, you're saying to yourself, how do you make this available to the masses, right? So that's the things that I still bring to the market here. And that is, everything we do here is with respect to saying, how can we get all the way down to STEM level activities, high school, and they're all getting smarter. and they all have phones,
right? And
they're all used to apps. How can you get software down to the point where you can make it so simple to use?
Right.
If I could sell,
it's back to that user experience you were talking about, user interaction
how can you optimize
design.
And take those answers and build them in so that you're optimizing what they do. They don't get stuck on the same thing all the time.
Right.
And oh, by the way, okay, maybe so you can drop your price. But if you're selling multiple millions more of it, then you've made up that money. And then it's like any you go out to your iPhone now. I am a neophyte with my kids. It took me forever to figure out what LLL meant, right? So, but the point is that there's lots of applications out there. People just grab them. Some of them don't even you don't charge for, but they're still getting paid based on those apps, right? So how can you take a process, make the engineering factory such that everybody in every place says, I need that application to run. So, but that means you have to do your due diligence and maybe focus specifically on areas.
Well, I think this is a great segue, actually. This tour that we're seeing pass by right now, and even what you were saying about education and STEM education and kind of being able to adapt to younger and younger audiences is relevant to the space that we're in, Lift. So I would love to give a little more context to what Siemens is doing here. So Siemens has been here, you said, a little over 2 years.
Yeah.
But Lift has been here maybe 10?
About 10 years.
Okay.
Yeah, so
and
Lift is about 10 years old.
Tell us more about what Lift is and what they're trying to do.
Yeah, so Lift, the acronym has changed over the years. When Lift first started about 10 years ago, it was really all about materials development, lightweighting of materials. If you look at various industries, whether it was aerospace or automotive, it was about doing more lightweighting of the materials, right? How can I take an automobile? How can I get more distance out of the automobile? And I don't have much to do on the internal combustion engine side, right? So, and it's kind of morphed over time. So lightweight innovation for tomorrow, leading technology for tomorrow. I mean, learning for tomorrow. So in this building is a combination of looking at projects that are relative to research and development, things like materials development, things like, and we get involved because it's materials and processes. In our case, this is all process development behind us on the machine. There's also learning labs here. So there's learning labs for people that come out of the service, because this is very heavy on the Department of Defense. And, there's also learning labs here for STEM activity. So kids can come here and get certified as welders or certified as automation people.
And I thought it was really interesting. Sorry to interrupt again, but there's so much to cover here. What you were saying about the welding certification program, when we toured the space, I loved the idea around the simulation and the kind of getting the certificate through a virtual kind of test, right? And process.
Which is important, right? Because you take younger people, for instance, and you want to get them trained. Putting a welding gun in their hand,
be a little risky.
Right?
Just a little.
But they have these virtual training systems now where you can actually get feedback on how you're doing relative to your welding process.
And that kind
of all virtual.
Gamifies it in a way, which I think is relevant to how younger folks are learning.
And yet still providing you feedback and engineering feedback to say you are good or bad,
meeting
and knowing
them where they're
that's
at.
Realistic, right?
Yeah. It reminds me of the typing games I got to play in elementary school when we were learning how to type. It was, it was only fun because they made it into a game.
My typing was learned when somebody says, hey, you needed to go on the CAD system. At that point, I was 2 fingers. I can type now.
Yeah.
It's like, if I think about it, I mess it up. But if I don't think about it, I can actually type.
If you just let it,
when I first started,
let it flow through.
When I first started, it was like this. I remember my father who passed away about 10 years ago. But he, oddly enough, he was a great musician. Again, musician, math,
a Renaissance man.
It's all kind of math, right? But he also in high school took a typing course. So as you were watching my father watch something on TV, you go over their house, he'd be typing. on his lab.
Oh, wow, just to practice it.
If he'd hear something, he'd start to it's like, what are you doing? He said, I don't know. He says, it's just one of those things that when you take a typing class, you just. So anyways, no, it's very important here to I love to engage with the students. We probably Lyft brings a lot of students in. We get engaged with a lot of college people. So Wayne State University is down the road. I've made some presentations on their campus. Mm-hmm. They've had some PhDs come in here. We try to engage. Matter of fact, the driving simulator over there, Wayne State and University of Michigan, the two PhDs or professors, they're sisters. So, but again, it is a learning lab, and we try to make sure that there's access to it. Now, we don't necessarily get into STEM level training. We when they come here, we try to talk to them, teach them, get them.
Might get their foot in the door though. Yeah. And again, like you said, it's that kind of inspiration maybe, and planting the seed.
Yeah, when you say about inspiration, one time we had some students here, and I got up there and talked to him, and I said, I've been doing this for 40 years. I said, I love what I do. I said, I'll do it for another 40 if I could. And I said, so you get done talking to them, they see the passion, because I do have a passion for this, right? Yeah. To me, it's not a job. It's not a living. It's an adventure. It's something where you can apply whatever you want to. Actually, I had one of the kids come up to me in class. He said, now I have to go home and tell my parents I don't want to be a doctor. I want to be an engineer.
Wow.
So,
That's awesome.
And then you walk away with some, just makes you feel
sweet.
good. It's like,
totally.
Oh, I'm sorry, but no, it was.
They shouldn't be too upset. Engineering is, I would say.
But again, it's you can map your own path. As you know, there's so many different aspects of what we do. You know, supply chain, design, data management, big data. I just one of our interns is going to be he's in school for big data. Huge opportunity, right? I mean, in this day and age, everything is pumping out something. Your phone is pumping out data. What do you do with the data?
Right.
And that's the optimization techniques that this machine behind us is really going to be helped with is people who are data analysts. So data analysts in the old days was somebody taking a look at the cards and the punch card. Yeah. It's not that way anymore. It's really somebody who can take a look at the stuff that's coming from the machine and try and figure out what are the right bits
filter
and
out
bytes
what's necessary, like you said.
That makes sense to optimize around.
Yeah.
And that's what this environment, this as I call it, like a playground. You know, I had one of the managers say, "Are we paying him to be there? He's way too happy."
He's way too happy. That's so tragic for them to say that. And then the kid, on the other hand, is like, wow, it's so inspiring to see your passion. You got to show them that.
That's right. So anyways, it's, every day we have a lot of things that I said to you, I think I said this to you. This is my house. I treat it like my house. I've mopped floors in there, and you just do what you have to do.
It's the same for us at Design
Yeah.
No job is, below you. It's
that's
like,
right.
Because if you have a pride in your space and what you do, then every little bit matters.
And that translates down, right? Because then I can tell you the staff here is 40 years younger than me, but they all do it too. I don't have to ask them. They just know that this is their house. You treat it with respect. And then we come out here and we talk about the projects we have to do. Yeah. How do we elevate the experience? That's one of the big things in these places, by the way, is I have to change just like everything else. I think I mentioned, it's like, you can get into the marketing Me Too side, right? If everybody's doing it, they can go see it anywhere. How do you take an environment like this and make it so exciting that they want to be here?
Yeah.
That they don't want to pretend the COVID stuff and saying, hey, I can do a Teams meeting. You don't get this experience back here.
Yeah.
You come out here, you want to go walk by the machine, you can see it. We haven't even talked. We have a KUKA mobile robot here that I call the butler. I mean, essentially, I have flexibility in the conveyor system. Then I have a mobile robot that adds another level of complexity to it.
Have you guys thought about having, since obviously we have all the digital twin capabilities, have you thought about having a virtual, version that people can walk through online?
We're working on.
Okay.
So
it's coming.
It's coming.
Stay tuned. You heard it here first.
Yeah. Well, hence my cameras for one. So I want to be able to do that type of walkthrough. And then we are putting this information in the common industry environment. So we were kind of, at the same time you get a building like this, you're building it, and all of a sudden it's like you have to pick and choose. You have limited staff. You have to pick and choose which thing you tackle, right? So, but now the virtual is tied to the real, and these two together. And yes, we are going to be offering that level. I mean, again, I prefer that people come visit us.
Of course.
But if it sparks interest to get there, then that's the whole purpose of showing them what's there, right?
And it just fits so perfectly with what this technology is capable of, and being able to demonstrate that. So it's kind of hard to resist, even if you do want the people here in person.
I agree. And again, for us, it's yes, this manufacturing system is all capable. At the end of the day, I'm not making anything for sale. I'm not making parts that I'm going to sell back to somebody else. So we know that if we build something in a day and we built 100 of them, then we have to take 100 of them all apart and put them back in the parts bin. It's just the way it is. Yeah. Right. So this is really to demonstrate capability and functionality. Whether it's this robot, this robot behind me, which has a different level of camera or visibility than the camera down there. This one can actually get into real fine detail, and becomes your quality check system. So you got all these systems that are linked together, manual stations, and so it's
dynamic.
It is very dynamic, and that's the hardest part. Is if you talk to my programmers on here, it's like you have to pick it off in phases, because you can actually add so many things in your mind. It's like if you dropped all these things on the board, you'd say, I don't know if we're going to get to number 32. I got to get to number 2 first.
So, definitely.
Anyways, one of my ideas here is that I want to have live look-in capabilities. I mean, Lyft has its camera systems around here too, but I want the abilities. Not everybody can travel, right? So can I get people to, whether it's account orchestration, specific customers, to get a look at what we're doing? I'm not trying to peek in to make sure somebody's doing work, right?
But no, it's like you were saying.
The idea is that if I do it here and I do one upstairs and I do one in the back, that I can offer that up as so if management goes out on the road, or so, then they can say, hey, this is what we're doing and this is what it's like, and trying to entice people to come to an environment like this, because you're here, you see the value of something. It's really impressive, right? Yes, it's a simple machine, but it's still very complex. I was just talking to the guys, but it's very complex in how it works, right?
Absolutely.
And so if you can show somebody what's available, what we can do here, for instance, knowing that we are trying to espouse digital threads, right? And most people have gone down some level of digital journey. They're not all through the journey, right? So the idea here is that we show them the depth that we as Siemens can take them on that journey. And as I said to you the other day, I like to also think of it as a fabric, because a thread assumes that even if it's a rope, it's multiple things in there, but it's still fairly contained. But a fabric means that you got the suppliers, you got everybody that's involved that you have to coordinate through. So hopefully the idea is that trying to get people to come here. And when COVID was hot and heavy, we're still seeing that thing where people would, hey, we can do this in a Teams meeting, right? There's something different about being on the floor. It's not the same. And it sparks some thought processes that we don't have all the necessary use cases to go down that road with everybody, but we certainly have the technology in the building, including tie-ins to, the Amazon cloud with our digital backbone, to show people this is how it works, right? So hopefully, we can, every vertical has different threads. Our verticals that we're supporting here is auto, industrial machinery, and heavy equipment. Very similar threads in that context. Discrete-based type manufacturing. You can kind of venture. A lot of companies are getting into multiple areas, so you still venture across there. But the idea is that there's probably one or two, maybe 6 threads that are part of a particular vertical that you can get into and just start to dig down deep, find out where they're at. Because somebody usually has some hole they didn't know was in their system. And anytime you have a hole, it's like it leaks, right? As I explained to somebody, you pull on a thread on a piece of fabric, and depending on the type of fabric, it can start to run. And it can start to let data start going out. And then if you want to fix it, as I keep preaching to the team that works on this machine here, we have to make sure it's always kept up to date. Because if somebody came up to me tomorrow and said, build another one of these, I need to have the latest and greatest material to say, here it is, go build it. So that's the type of thing that, we do here. We're also, so we're 2 things. One is in the conference area where we try to do that. We bring them out to the floor. We go back in the conference room. We try to get them to work through where they're at. And then we try to tie in where we're at and where we can help them, right? And usually we don't talk about our individual applications. Obviously, you're at Siemens.
Right.
Or a place that has Siemens in it. In our case, it's a matter of, hey, our expertise in this company, folks like yourself and me, we've been doing this a long time. So you get different people that can talk to you about, hey, I've been doing CAD work forever, or I've been doing manufacturing work forever. So that we can start to talk to them in their speak, right? To try and work through the issues, to try and say, hey, we can help you. Even if it's not ours, we can still help you.
But fit it into the bigger picture of like what you're saying, the fabric.
Yeah, fit it into that picture right back there. That's part of Explore, right? And Explore is a big concept to really wrap your head around. And people all have different pieces, right? In the old days, because I'm an old person, in the old days, you there was always that concept of throwing things over the wall. Somebody wanted to finish their job before they gave it to somebody else. And that can't happen nowadays. In the compressed time frames that we have, you have to be able to work together. So when you walk through our experience here, each thread is talked about on one of the monitors we have here. But the threads are meant to have a discussion that says, yeah, just because you're at station 1, you are probably impacting something that's going on at station 7. So, and that's why I say, instead of having a thread that looks like you're going a serial process through, you really are a fabric that says, I'm over here, you're over here, but all that stuff is connected inside the fabric somewhere. So that's the whole purpose, is to bring them out here to spark just to plant the seed, to let it grow. And then when you get them into the conference area, we start to draw on the whiteboards and capture all of it. And, there's always the vision of what is your 5-year plan or longer. And some people want to talk about that. Some people also want to address, I have short-term goals. We get a lot of smaller SMB type accounts that come in. They really understand they have a specific problem. They're very in tune with it. So you can start there, but then they ultimately start migrating towards this bigger picture of, where do I need to go? Because in the end, your problem may be here, but it probably started somewhere else.
Definitely.
So, that's kind of our take here. Now we have a staff of engineers. We use this also as what I consider our workforce development. I mean, Miss Humpton was here, and she really espouses that type of stuff. And so we have a lot of young engineers who learn, teach. They work out of pre-sales, so they get a combination of customer experience. Plus, they get to do some things here. And as I told them, I said, grab a wrench, because it's not uncommon for us to be climbing underneath the machine, putting some belts on that we broke or something. Right?
Absolutely. So, okay, so I want to be conscientious of our time here. I don't want to have to replace the camera battery one more time. So we're going to wrap it up with just 2 more questions. One, I wanted to get back to a little bit more about LIFT. You mentioned the material science and material research. I know that you said that's not necessarily the biggest part of what they do now, but you did tell us during our tour some interesting examples of some of the materials that they're developing and the companies that are working here on that. I would love for you to just kind of short and sweet, tell us about the foundry that they're developing, and also, if you can, is that okay?
And then I don't know all the particulars, right?
That's okay.
This is a lift type activity. It can be
bigger picture, but also the some of the 3D printers, the additive materials that capabilities that they have here at the space, I think are interesting.
Yeah. So lift has a specific focus, as I kind of said earlier. Lightweighting, materials development, material process. So material process is a huge thing, right? So in their case, they can come up with a new composite or material, whatever it happens to be, compound, but they also have to be able to certify that you can control the process, that it's consistent, right? It's like anything else. If you're going to try and put something on a critical component on some sort of vehicle and it breaks, you put somebody at risk. So it's a combination of materials and then also process and then systems. Now here, there are projects for things like hypersonics, which is, I personally am not a metallurgist, but to find out that, you watch the movies, I think it was in Top Gun Maverick or something, right? And it was like, okay, something that goes Mach 8. Well, I had no idea that metal starts to flake apart at Mach 8 or something, right? Point is here is that they look at these materials, they start to figure out the process to control that. Now, they do have some capabilities in terms of things like additive. It's not a facility to develop additive technology. It's a facility to take additive technology and optimize the build process.
Got it.
So they have a metal printer in the back that's made of powder. They have a cold spray fusion machine back there, which is a little bit different type additive type process. They also found a need in the marketplace to, as they work with universities and everybody else that's tied to this member community, which is what it is. Projects yield, okay, this is a new material. People want to test the material. Well, there's this whole thing of where do I get the materials made? And what they found is that over in the US, a company wants to build large volumes of the material when somebody only needs a box worth, right? So Lift is putting in its own, what I think is a foundry type thing that says, hey, we have an atomizer, we can make powder, we can make whatever for the industry to start doing. So they found a niche, met a niche and said, okay, we have the ability to produce materials for use in the additional formal testing for industry acceptance type stuff. So it's they've been rebuilding that thing in the back there. They also have a older technology like wire arc additives. They got 2 robots doing a dance. And I think as I explained, some of their the ideas is that how can you have a smooth, reduced footprint to develop technologies to be used out in the field when you can't put up a big building like this for specific reasons.
Makes sense. That's really necessary. Like you said, huge market.
And we're tied to it, by the way. So there are other things. When you get into the systems engineering, we actually hold some virtual commissioning workshops for that.
Very cool.
So we're tying, we were just on the phone before you got here and tying in corporate technologies to try and figure out how can they lend their expertise into some of the projects that the government says they need funding for.
Awesome. All right. Well, our finale question, we made it to the end here, is what is on your personal bill of materials? We're on the BOM. You know what BOM stands for. So what's on your personal Tom Hoffman bill of materials?
As it relates to this building?
You can interpret it however you want.
Well, to work, first off, work as long as I can. But so I want this place to keep moving forward to drive. So from a business standpoint, to keep driving forward with our sales. Yes, I have a place that I can talk to generically, but I also have a place that we want to drive sales and help the customer. So if I can show I can help the customer, that in turn drives software gets developed, and we can keep enhancing the experience for the customer, keep developing the software to make it easier for the customer to use. So that, and that in turn will drive the potential for me to get a larger staff here to do some of this. And teaching younger students and they're not even, some are not even students. They come here, they go through our process, they become young. And then I am an open book with the kids. I call them my kids. I like my kids. So I'm an open book. I teach them as much as I can. And then I learn because they have learned stuff in school and stuff that I don't know. And so if I can learn that. So I'm an open book. I like to think of it as the mind is always working, right? You know, I people think I'm crazy at times, and I'll tell them, I got up at 4:30 this morning because I was thinking about something you said the other day, and I went right onto the computer before I get here at 6 o'clock in the morning. And people, you know, they say, I can't believe it. And then what you find out is that they start doing the same thing, and then they start showing up early. So, so that's the business side. I'd like to be I manage a place, but right now there's a lot of people involved who are not necessarily reporting to me. I want to build a bigger reporting structure here for me, and therefore, so I can
support
more,
this progress.
More, right?
Makes
Personally,
sense.
Just watch my family grow. I got 8 grandkids now, you know, and to me, I had one of them whose mom is a doctor tell me that she wanted to be an engineer now too. So, you know, to me, it's the promotion of what we do. And, you know, don't be afraid to get your fingernails dirty type stuff. It's like I told the interns the other day, don't be surprised if I ask you to pick up a wrench.
Absolutely.
And I'll show you how to use a wrench, you know.
Absolutely.
So that's just my personal, you know, again, that's, if it ever becomes a job, then I don't want to do it. Right now, it's not a job.
That's beautiful. I think that's what everyone strives for, honestly. So thank you so much for your time today, Tom.
Magic.
It was really great to, I got that.
You got
You're
it.
going to start the trend. And I'm really excited to see how this place grows. Hopefully I'll get to visit you guys in the future,
I hope so.
see that new material, process as well
And
when I get back.
I should be putting your stuff in here.
Yes, absolutely. We're going to see Supplyframe here in the future. I got that on tape now, so it's official. And just thank you so much for the insight and expertise. It was an awesome conversation. Excited to follow along your work in the future.
People know, you know how to get a hold of me, and you can always publish my email address.
Yes, definitely. We'll include it all in the show notes. That was my conversation with Tom Hoffman. You can find out more about Siemens and Lift in the show notes. Thanks for listening. We'll see you next time. If you like The Bomb, don't forget to subscribe, rate, and share the show wherever you get your podcasts. You can follow Supplyframe and Hackaday on Instagram, Twitter, LinkedIn, YouTube, and DesignLab at Supplyframe DesignLab on Instagram and Twitter. The Bomb is a Supplyframe podcast produced by me, Majenta Strongheart, and Ryan Tillotson. Written by Maggie Bowles and edited by Daniel Ferreira. Theme music is by Anna Hogbin, show art by Thomas Schneider. Special thanks to Giovanni Salinas, Bruce Dominguez, Thomas Woodward, Jin Kumar, Jordan Clark, the entire Supplyframe team, and you, our wonderful listeners. I'm your host, Majenta Strongheart. See you next week.